What are actually the different cleaning methods being used for stainless steel systems in biopharmaceutical or semiconductor-oriented system manufacturing? I will explain the most important ones. Hi, I'm Thorsten Köcher, and I would like to bring you across some of the most important cleaning methods being in use for biopharmaceutical or semiconductor processes. So whatever hygienic process you may look for, there are certain questions arising from this topic. As an initial step, usually highly hygienic tubing, such as this here, is being cleaned in a first step using Tcc cleaning. So what is Tcc cleaning? Tcc cleaning is being described in the ASTM A632, and it's being described as a thermocouple clean condition. So what is this? In this process being described there, you would use a lint-free artificial cloth being soaked with, for example, isopropanol and either pulled or pushed multiple times through the tube. The result of this shall be either a completely clean cloth or a probably slightly gray one. Then this process is being considered as successfully passed. This sample here shows you the result of such Tcc cleaning process. And in this one, you see that a visually good cleaned surface is the result. The question is certainly if this result is matching with the requirements of your process. If not, further cleaning processes have to be applied. And you can distinguish these cleaning processes being either abrasive or non-abrasive. As an abrasive cleaning process, also a chemical cleaning process is being considered. For example, cleaning with HF, also called pickling. So a pickling process is being described as using roughly 5%, 4% hydrofluoric acid in and what certainly matters as well is the exposition time, is the temperature. However, such process being applied can be also in disadvantage of the part. When it may take too long or the material has certain undesired properties, you may damage this part significantly in this process. However, further or a different approach would be an electrochemical cleaning process. That could be either analytical cleaning or could be electropolishing. Both processes are more or less the same. One is faster than the other, but both have in common that there the part is introduced in a DC circuit, whereas your to be cleaned part is the anode where the oxidation happens. So you take off some of the surface and bring it into solution, and at the cathode you would have the creation of hydrogen. However, at an analytical cleaning process you would take off roughly 5 micrometer. In an electropolishing process you would roughly take away 20 micrometer. So electropolishing also means considerable smoothing of the surface. Here I brought with you a sample that has been electropolished from the inside. So it's a pretty special one, as you can see here. And the question is, this part, if this part would need further cleaning, what would you do? You can clean it from the outside, for example, by supersonic cleaning. At a supersonic cleaning, you have a supersonic emitter that emits a sound beam to the surface. And this sound beam consists of a modulation of pressure. And during the low pressure phase, small bubbles will be being created at the surface. And during the high pressure phase, these bubbles are collapsing. let's say, imploding. All these processes being called cavitation. So this cavitation that will happen on the surface will lead up to punctual and very temporal pressure increases of pressures up to 1000 bar. And this pressure increase will lead to very high cleaning success on the surface. However, unfortunately, you can only use this supersonic cleaning with regard to the outer surface. If your interest is to the inner surface, that will not work, due to the fact that these emitters have a certain geometry, and it would be very difficult to introduce a emitter into this surface here, or into this part. Yeah? Especially when you are considering such parts where you have this geometry, it would be very difficult to clean this with ultrasonic sound on the inside. However, we apply CNP cleaning to this. CNP cleaning means cyclic nucleation process. In this CNP cleaning process, the mentioned pressure modulation will not be created by a sound wave, it will be created by a mechanical pumping system. This mechanical pumping system creates also the effect of cavitation, but it will create it on the inner surface and on the outer surface, right? So this CNP cleaning process will result in a very clean part on the inside and the outside. This cleanliness can be certainly verified by using, for example, residual gas analysis, yeah? Or other processes following that. This is basically what I would like to tell you about the different methods of cleaning, be it either TCC, be it pickling, be it analytical cleaning, be it electropolishing, supersonic cleaning, or CNP cleaning. If this contribution from our side is causing questions to you, is causing, for example, also questions to what you do with your application, we would certainly be happy to assist you, and we would certainly be very much interested in cooperation and in exchanging ideas with you. Yeah, not much more to say than thanks a lot for your attention. I would be very happy about a thumb up towards this video, and I would be certainly also very happy if you would subscribe to our YouTube channel. Thanks so much, and see you next time.